and temporal, members of the academic community, distinguished ladies and gentlemen, you're welcome to the 179th Inaugural Lecture of this great university titled Earth's Atmosphere, the Modulator of our Climate and Terrestrial Biodiversity by Emmanuel Omonigho, Ogolo, Professor of Atmospheric Physics. In line with the tradition of our institution, this inaugural lecture will be presided over by our Vice Chancellor, the very first female Vice Chancellor of this institution, Professor Emmanuel, Fellow Academy of Science. You are welcome. We also have in our midst other principal officers of the university. Professor Taiwo Timothy Amos is the Deputy Vice Chancellor Academic. We also have in our midst Professor Sunday Samuel Oluyamo, Deputy Vice Chancellor Development. Our registrar is Mr. Charles Olusegun Adeleye. You are welcome, sir. We also have the University Bossa, Mr. Peter Oshagugba. Dr. Robert Akiade Awoyemi is the University Librarian, while Professor Ukwenya is the Acting Provost, College of Health Sciences. You are welcome, sir. Also, we have the deans of our various schools here. We have the Dean, School of Environmental Technology, and also who is the Chairman, Committee of Dean's Futa, Professor Isaac Olaniyi Aje. Professor Oluwatoyin Faramade Oludamsi is the Dean, School of Agriculture and Agricultural Technology. Professor Akim Olalekan Lawal, Dean, School of Basic Medical Sciences. We also have in our midst Professor Boniface Kayode Aleshe, is the Dean, School of Computing and member of our Governing Council. We have Professor Peter Kayode Oke, is the Dean, School of Infrastructure, Minerals, Manufacturing, Engineering. Professor Adewoke Oladipo Melody is the Dean, School of Electrical Systems Engineering. We also have in our midst Professor Olayemi Oladende Samuel Oke is the Dean, School of Logistics, Innovation, Technology. Professor Michael Olufemi Ashamo is the Dean, School of Life Sciences. The Dean, School of Physical Sciences is Professor Femi Barnabas Adebola. Professor Oluwayo Bello Olusoji is the Dean, School of Postgraduate Studies. While the Dean, Student Affairs is Professor David Olaiwaju Oke. Once again, I would like to introduce our inaugural lecturer, Professor Emmanuel Omonigho Ogolo. Distinguished ladies and gentlemen, I would like to invite our Vice Chancellor, Professor Adenike Temidayo Olajuji, FAS, for a welcome address. The Vice Chancellor.
The Deputy Vice Chancellor Academic, Deputy Vice Chancellor Development, the University Librarian, the Bossa, the Registrar, my lords, spiritual and temporal, top government functionaries here present, the inaugural lecturer of today, Professor Emmanuel Omonigho Ogolo, deans, directors, and heads of departments, especially the Dean of the School of Physical Sciences, distinguished members of Senate and congregation, eminent scholars and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. I welcome you with great pleasure to the 179th Inaugural Lecture of the Federal University of Technology at Prof. I warmly welcome our spiritual and traditional leaders, top government functionaries, captains of industries, friends of the university, and the entire staff and students of our great university. I am delighted to welcome the immediate and the extended family members, friends, and well-wishers of the inaugural lecturer. I felicitate Professor Emmanuel Ogolo on this academic milestone. May I, at this juncture, request the inaugural lecturer to please rise while I present his citation. Professor Ogolo, please. Emmanuel Omonigho Ogolo was born on the 6th of June 1959 in Okitipupa, Ondo State. He had his secondary education at CSC Teachers College, F1 between 1979 and 1982, and proceeded to Adeyemi College of Education, where he obtained the NCE in Mathematics and Physics in 1986, Obafemi Awolowo University, Ile-Ife. He has BSc Education Physics in 1992, and University of Ibadan. He obtained MSc and PhD in Atmospheric Physics between 1995 and 2002. Emmanuel Omonigho Ogolo joined the services of the Federal University of Technology Akure as Lecturer 1 in the Department of Physics in 2004 and was appointed Professor in 2014. Professor Emmanuel Omonigho Ogolo had supervised many undergraduate and master's degree students and successfully mentored over 10 PhD students. He has served as external examiner to several universities in Nigeria, besides involvement in the assessment of candidates into the professorial career. His research focuses on atmospheric physics, meteorology, and renewable energy. His work encompasses solar radiation modeling, evapotranspiration studies, wind energy potential assessment, and climate change impact analysis. He has authored over 60 publications in both local and international journals. He is a reviewer for several academic and professional journals, including the Nigerian Journal of Pure and Applied Physics and Journal of Modeling Earth Systems, among others. Professor Ogolo's commitment to advancing atmospheric research is demonstrated through his participation in international field campaigns, such as the Nigerian Micrometeorological Experiment 2004 to 2009 and Dynamics Aerosol Chemistry Cloud Interactions in West Africa between 2014 and 2018. He belonged to several professional bodies, including the Science Teachers Association of Nigeria, the Nigerian Institute of Physics, the Nigerian Meteorological Society, and the International Union of Radio Science, Nigeria. Professor Ogolo has had years of experience both in lectureship and management positions in the university system. He has served the university in many capacities, such as head of Department of Physics, member, University Admissions Committee, and member, Business Committee of Senate, and several others. Outside the university, he is the patron, Nigerian Atmospheric Research Group, patron, Atmospheric Research Network of Nigeria, National Church Growth Officer for the Redeemed Christian Church of God, Osogbo, and Regional Coordinator for Region 43 and former Region 3 of the Osogbo and Ile-Ife parishes respectively. He has also served as external examiner and assessor to other universities in Nigeria, including Obafemi Awolowo University, Ile-Ife, Ekiti State University, Ado-Ekiti, University of Ibadan, and University of Ilorin. Prof. Emmanuel Ogolo is married, and the union is blessed with children. The Earth's atmosphere critically regulates climate and biodiversity by controlling temperature, precipitation, and energy exchange between solar radiation and terrestrial systems. This fundamental relationship supports ecosystem health and species distribution worldwide. Understanding atmospheric processes bridges multiple scientific disciplines and informs environmental policies, conservation strategies, and climate adaptation efforts, making it essential for addressing today's environmental challenges. This lecture is expected to enlighten us on how the atmosphere regulates climate, energy balance, biodiversity, and the need for sustainable atmospheric management. Distinguished ladies and gentlemen, we have before us this day to present the 179th Inaugural Lecture of the University, titled Earth's Atmosphere, the Modulator of our Climate and Terrestrial Biodiversity. Please join me as I welcome Professor Emmanuel Omonigho Ogolo.
The Vice Chancellor, other Vice Chancellors, Deputy Vice Chancellors, Registrars, other principal officers of the University, Deans and Directors, Heads of Department, Members of Senate, distinguished professors, distinguished academic colleagues, administrative technical, my Lord spiritual and temporal, distinguished professionals and academic colleagues, invited guests, friends of the universities, great Futarians, members of the press, and distinguished ladies and gentlemen. Madam Vice Chancellor, I stand here today filled with profound gratitude to God Almighty, the giver of life, wisdom, and every good gift. It is by His grace alone that I have been granted the privilege to deliver this inaugural lecture. The words of Psalm truly encapsulate my testimony. This is the Lord's doing. It is marvelous in our eyes. I reflect on the journey that has brought me to this point, and I am reminded of the words in Lamentations. It is of the Lord's mercy that we are not consumed, because His compassion faileth not. They are new every morning, great is thy faithfulness. Indeed, God's faithfulness has been my anchor through life challenges, and His mercy has sustained me at every stage of my academic and personal journey. He gave to us my academic journey to atmospheric physics and beyond. Madam Vice Chancellor, distinguished guests, esteemed colleagues, and honor students, I stand before you today humbled and grateful for the opportunity to share my journey of life as I reflect on my path to becoming a scholar in atmospheric physics. I am reminded of the power of perseverance, the importance of mentorship, and boundless grace of God. My academic journey in tertiary education began at the College of Education in 1982, where I studied physics and mathematics. It was during this foundational stage that my passion for the sciences was nurtured. Academic college provided me not only with the technical knowledge to understand the physical world, but also the pedagogical skill to share the knowledge with others. This dual focus instilled in me a love for learning and teaching, which has remained with me throughout my career. I graduated with distinction in physics and mathematics, an accomplishment that reinforced my determination to pursue greater heights. Motivated by passion for education and desire to deepen my understanding of physics, I proceeded to the former University of Ife, now Emmanuel University, to study physics education. There, by the grace of God, I achieved a first-class degree in physics education. This milestone marked the turning point in my academic journey. Recognizing my potential and dedication, I was employed to the Department of Physics at the Adeyemi College of Education as an assistant lecturer immediately after graduation. This opportunity was not just a career advancement, it was the beginning of a purposeful journey into academia. A journey that will eventually lead me to the specialized field of atmospheric physics. While at Adeyemi College of Education, my desire to advance my study group, I aspire to pursue astronomy at the University of Ibadan despite the odds that against me. At the time, the Department of Physics at the University of Ibadan did not admit candidates with a background in education to study advanced physics. My first degree, being in physics education, initially posed a significant constraint. However, divine intervention came through the private assistance of Dr. Joseph Adekugbe from the Department of Mathematics at the university. We facilitated a meeting with Dr. C.S. Gadi and then the postgraduate coordinator who recognized my potential and sought a suitable supervisor. The eminent Professor E.O. Omonigho, founded College Joe by his peers, graciously agreed to supervise me. Hence, my unconventional journey to study astronomy at the University of Ibadan and the strong determination to break barriers. Professor Omonigho's mentorship became a turning point in my desire in an academic journey. His willingness to guide me not only opened the door to postgraduate studies, but also introduced me to a fascinating world of atmospheric physics. This shift in focus laid the foundation for a lifelong passion for understanding the complexities of the atmosphere and its intricate intersection with the Earth system. From physics to atmospheric synergy, a story of advocacy and impact. Madam Vice Chancellor, my master's degree program in atmospheric physics marked a significant turning point. Against the odds mentioned earlier, I did not only excel academically, but also emerged as one of the 10 candidates out of 24 who made the PhD grades. This accomplishment not only solidified my academic trajectory, but also broke barriers, paving the way for students with a similar background to pursue higher degrees in physics at the University of Ibadan. It underscores the power of perseverance and the transformative impact of academic excellence, leaving a legacy of inclusion and opportunity. Embodied by the success of my master's degree program, I confidently embarked on a PhD in atmospheric physics under the continued mentorship of my academic father, Professor Omonigho. His steady guidance and expertise were invaluable as I delved deeper into my research, further honing my skill and expanding my knowledge in the field. Upon completing my PhD degree at the University of Ibadan, I was invited for an interview by the manager of the Federal University of Technology, Akure. During the interview, Professor J.J. Ogolo of the Department of Meteorology, recognizing the relevance of my services, of my expertise in atmospheric physics, proposed that my services should be more valuable in the Department of Meteorology. However, my then head of the department, Professor Emmanuel, strongly advocated me to remain in the Department of Physics, emphasizing that my solid background in physics would greatly benefit the department and its objectives. This decision not only solidified my appointment as a lecturer one in the Department of Physics in 2004, but also fostered a collaborative working relationship with the Department of Meteorology. This allowed me to continue meaningfully across both departments, leveraging my expertise to enhance interdisciplinary research and academic development. It is with great pleasure and delight, as well as uncommon privilege and honor, that I stand before you to deliver the 179th Inaugural Lecture of this great university. Earth, ocean, and human environment in relation to the sun as the external forces provided the initial impetus to develop the field of physics. Climate is the primary driver of the distribution of plants and animal species, significantly influencing their growth, development, species composition, geographical distribution, and community diversity. Within ecosystems, plant-animal interactions are crucial for ecosystem functioning, biodiversity, and successful restoration. Ecosystems also play a vital role in climate change. Mitigation and adaptation by providing services that reduce carbon emission and mitigate the impact of extreme climate events such as unpredictable weather, flood, droughts, and severe conditions. Terrestrial ecosystems are closely linked to atmospheric carbon dioxide level through processes like photosynthetic carbon dioxide fixation, carbon sequestration in biomass and soil, and carbon dioxide release by respiration and deposition of organic matter. These processes underscore the interconnections of ecosystems and climate dynamics. Large increase in greenhouse gases emissions since 1970s. Industrial revolution are the main drivers of climate change. This has led to more frequent and intense natural disasters, rising sea levels, reduced crop productivity, and biodiversity loss globally. Understanding the direction and manner of ecological response to climate change is crucial for human adaptation. As human population grows, urbanization intensifies, and natural resources are exploited, biodiversity faces increasing pressure. Without action, ecosystem will degrade further. As species will go extinct and ecosystem will become less functional. Let me start my lecture by reflecting on the biblical narrative from the book of Genesis, which beautifully illustrates the divine origin of Earth's climate system. This system created by God is a complex interplay of the sun, atmosphere, lithosphere, hydrosphere, biosphere, and cryosphere. These components work together harmoniously to sustain life on Earth. However, over time, human activities such as burning fossil fuel, deforestation, urbanization, and agricultural expansion have disrupted this delicate balance. These unguided anthropogenic activities in action have led to significant environmental challenges, including climate change, habitat destruction, and biodiversity loss. I also reference Prophet Joel's vision, which speaks of the trembling earth, darkened sky, as a metaphor for the urgent need to address the climate crisis. This vision underscores the importance of atmospheric physics and meteorology in understanding and mitigating the impact of climate change, ensuring that Earth remains a habitable place for both flora and fauna. The Earth's atmosphere. The Earth's atmosphere is a volume of air surrounding our planet Earth, held by gravity. It is essential for life, climate regulation, and protection from space aside. It consists of 78% nitrogen, 21% oxygen, 1% of other trace gases. It is divided into 5 layers, with different characteristics. I start with the troposphere. The troposphere is between 0 to 80 kilometers. That is where weather occurs, including cloud formations, storm occurrence, and precipitation. But rising carbon dioxide level intensifying heat waves, global warming, tropical storm, commercial air and operating air, and shortwave radiation and weather balloon functions within this layer. This is followed strictly by the layer called the stratosphere. The stratosphere is between 18 to 50 kilometers, and this contains the house and household of the ozone layer, which protect life from UV radiation. My research phenomenon, in 2008, confirmed that banning chlorofluorocarbons help heal this layer, proving the effectiveness of scientific policy. It also regulates Earth's temperature and holds long-range aircraft and stratospheric balloons. Other layers include mesosphere, thermosphere, exosphere. The benefit of the atmospheric studies. The atmosphere is essential for life, providing oxygen, regulating temperature, and protecting against harmful solar radiation. So, stratospheric ozone absorbs ultraviolet radiation, preventing damage to living organisms. Meteorological services provide critical information for weather forecasting, climate monitoring, and disaster management, helping society adapt to changing environmental conditions. Global solar radiation. Global solar radiation is the primary energy source driving the Earth's climate system. Global solar radiation consists of direct and diffuse radiation, influencing surface energy balance, weather patterns, and climate dynamics. Accurate measurement of global solar radiation is essential for application in solar energy, agriculture, and climate modeling. However, in tropical regions like Nigeria, limited infrastructure and high cost hinder continuous solar radiation monitoring, leading to reliance on empirical models. Regional climate of West Africa. West Africa climate, extensively documented by researchers from Waters and Light 1960 to Yo and Ogolo 2021, is governed by the interplay of UV southwest boson winds from the Atlantic Oceans and dry Harmattan trade wind from the Sahara, and separated by the seasonal intertropical convergence zone migration. This dynamic drives critically the wet and dry season that sustain regional agriculture and ecosystem. However, climate change is not disrupting this pattern, causing destructive flood in southern Nigeria and northern drought, with severe implications for food security. As traditional weather patterns become unreliable, urgent scientific and ethical action is needed to address the growing climate crisis. The increasing computability demands immediate interdisciplinary solution to this escalating crisis. Contribution to the body of knowledge. Atmospheric physics and meteorology-based service and process phenomenon in Nigeria. My research team and I have made significant contribution to understanding Nigerian tropical wet and dry climate as documented by Ogolo and Ogolo 2007. The country's weather pattern are driven by the seasonal migration of the intertropical continuity, which define the wet season, April to October in the south, May to September in the north, and the dry season, which is from November to March in the south, October to April in the north. This seasonal shift played a crucial role in agriculture, water resources, and biodiversity, as documented by Ogolo 1981, Ogolo et al. 2004. Sunshine, solar radiation, and net solar radiation. The Earth's energy balance is driven by the progressive rate of the radiation from the sun and the planet's own emission. Sunshine, solar radiation, and net radiation are the three components influencing climate, weather, and ecosystem. The balance of incoming and outgoing solar radiation and terrestrial radiation drive key climate processes like evapotranspiration and photosynthesis. Ogolo et al. 2009 focused on the variation of global and net structural radiation and net long-wave radiation during a transition period in southwestern Nigeria. This results had crucial insight into the local climate dynamics during transition season and providing vital information for applications spanning from agriculture to energy management. Ogolo and others, 2021, examined the impact of radiation balance on warming in West Africa and found significant regional variation in net radiation across Nigeria. Higher values were obtained than south in the humid southern zone due to low albedo and high humidity, while lower value occurred in the arid north due to high dust concentration as illustrated in Video 3. The study further revealed that incoming short-wave radiation influenced net radiation more in the humid zones than in the arid zone due to greater absorption by forests and water bodies, as illustrated in Figure 4. This finding highlights the role of radiation balance in climate dynamics and its potential impact on sea level rise and coastal flooding, posing risk to vulnerable communities. In a study conducted in Nigeria by Ogolo and Arabeshola 2006, it was found that cloudiness is an important factor influencing the radiation balance of the tropical atmosphere. The substantial difference between clear sky and cloud-adjusted net radiation highlight the cloudiness significant modulate tropical radiation balance, implying shift in cloud cover to alter regional climate patterns, disrupt ecosystem and threaten biodiversity by destabilizing the microclimate and hydrological cycle on which species habitat depends. Also, Matthew, Ogolo, and others, 2020 examined impact of cloudiness on near-surface radiation and temperature in Nigeria, West Africa. The study observed that cloudiness significantly perturbed the radiative balance, causing net cloud radiative cooling in Guinea savanna, but warming in the savanna and the Sahel zones as illustrated in Figure 5. The study highlighted that cloudiness-driven radiative imbalance has especially divergent impact, threatening Nigeria's climatic stability and biodiversity. Proactive regional climate adaptation and ecosystem-specific conservation strategies are critical to mitigate this extractive risk. Ogolo et al. 2025 compared various reanalysis products with observational data on global solar radiation over Nigeria. The study found that global solar radiation estimate from SRMK and the ERA interim product, the analysis align well with ground observation, showing correlation ranging from 0.43 to 0.7. However, the observed differences in global solar radiation estimates were linked to errors in cloudiness, parameterization, complex topography, and local atmospheric processes. The study emphasized the need for improved regional gas scaling and bias correction to enhance the accuracy of the analysis data product for climate impact studies. Ogolo et al. 2025 evaluated the impact of land use and land cover on radiation balance components in Lagos metropolis. The study revealed significant land use map changes between 1986 and 2016, with vegetation cover increasing from 81.8% to 52.82%, while residential area expanded from 12.87% to 38.26%. Analysis of radiation balance components show increased incoming solar radiation in highly urbanized areas and higher outgoing long-wave radiation in residential and commercial zones. The rapid urbanization and loss of vegetation have also led to habitat fragmentation, threatening biodiversity and reducing ecological resilience. This finding emphasizes the need for enhanced green spaces in urban planning to mitigate surface heating effect and biodiversity loss in Lagos. The 2009 study by Ogolo and Ogolo revealed that rising population, land use change, cloud cover, and greenhouse gas emissions significantly reduced net radiation across West Africa, especially in the humid zone. This factor contributed to surface warming by altering surface albedo and increasing carbon dioxide emissions. as illustrated in figure 6 from A to F, highlighting their impact across the regional climatic zone. The study emphasized how human activities and cloud dynamic jointly degrade West Africa relative balance, intensify climate biodiversity crisis, addressing population-driven land use changes, and mission is critical to safeguarding regional climate stability and ecosystem, temperature and precipitation. Temperature and precipitation are key indicators of climate change. Ogolo and Emmanuel 2009 investigated variation and trend of some meteorological parameters at Ibadan, Nigeria, and observed that the annual linear temperature in Ibadan showed a well-defined warming trend between 1989 and 1997, interrupted by cooling 1993 and to 1994. That's illustrated in figure 7. This is a signature of warming trend that is consistent with global pattern, interrupted by short cooling period. Ogolo 2007 analyzed long-term annual linear temperature trend in 5 Nigerian cities. Lagos and Ibadan show significant warming, while Calabar and Port Harcourt exhibited slight cooling, highlighting uncertainty in global warming debate. These variations indicate localized climate change effect, influencing rainfall pattern, heat stress, and extreme weather events. The findings have implications for biodiversity, as temperature shifts affect habitat stability, species migration, and agricultural productivity. Water vapor density, evaporation, evapotranspiration, and drought. The hydrological cycle, including evaporation, evapotranspiration, and precipitation, is critical for water resource management. Babatunde Ogolo and others from 2017 documented the correct evaluation of 4 evapotranspiration models based on energy covariance measurement over a ground cover surface in 11 southwestern Nigeria. It was a study that FAO model estimated ET by 14.7%, while Priscilla model overestimated by 94.1% as illustrated in figure 8. The result confirmed FAO model to be the most accurate. Ogolo 2011 investigated the impact of material variables on pan evaporation trend across Nigeria. The study revealed that during the 1970s, a period marked by global diamond, pan evaporation decreased in all regions except the Sahel, as illustrated in figure 9. This highlights the influence of solar diamond on evapotranspiration pattern and regional climate variability in Nigeria. Ogolo 2011 further observed that the increasing trend of pan evaporation across Nigeria is a signal to an increase in aridity in substantial parts of the country, particularly in the Sahel and Midland region. Ogolo 2014 evaluated the performance of the calibrated reference evaporation model across Nigerian diverse climatic regions. The study tested the actual hybrid marking and precipitation, adjusting their coefficient for regional conditions. Results show that actual models suited arid Sahel, while hybrid performed best in coastal savanna and midland region. The precipitation model required the most substantial calibration. Findings emphasize the need for region-specific evapotranspiration model for accurate water resource management. Ogolo 2007 carried out a study on the comparison of continental temperature-based and hybrid temperature and solar radiation-based model for estimating energy limited evapotranspiration in Ibadan. The finding revealed that continental had the lowest standard error of estimate and they had the lowest but underestimated ET by 1 millimeter per year, whereas hybrid was estimated by about 4 millimeters per year. Both models show strong correlation with estimated data, particularly in the dry and wet season. Accurate ETS models enhance drought resilience and irrigation efficiency in climate study. While in biodiversity conservation, they sustain soil moisture, crucial for rainfall ecosystem with proper calibration, ensuring habitat stability. Ogolo 2014 carried out a study on regional and seasonal sensitivity analysis of different evaporation methods for different climate conditions in Nigeria. Our findings further reveal that solar radiation and wind speed signaled drop evapotranspiration variability across Nigerian climate region, with temperature dominating in coastal areas, highlighting the need for region-specific climate model to improve water resource management and agricultural planning under changing climatic conditions. Akuwande, Ogolo, and 2004 carried out a study to evaluate the performance of SBI and SBI in detecting drought over various climatic zones in West Africa and compare their strength and limitation. The result revealed that both indices detected drought effectively, but SBI was more sensitive to evapotranspiration and temperature change. The findings offer valuable insight into climate change impact, drought monitoring, and sustainable water resource management. Ogolo et al. 2004 investigated the interconnection between climate parameters and reference evapotranspiration over Nigeria. The study found that reference evapotranspiration in Nigerian system has significantly correlated with climate parameters, showing strong relationship with related units in science, deep savanna, and coastal region. In addition, the trend analysis is increasing trend evapotranspiration in the science, deep savanna, and rainforest, while the coastal region experiences a decline, with 1999 as a critical change point. The study confirmed temperature, related humidity, and net vegetation as the key drivers, highlighting the need for tailored water resource management strategy in response to changing climatic conditions. Winds and renewable energy. My dedicated research team and I have made significant strides in the realm of renewable energy in Nigeria, particularly in the area of wind energy. Through our elaborate work as exemplified in Ogolo 2014, Ogolo 2019, Ogolo 2020, we have played a fundamental role in advancing the installation of wind energy in many cities in Nigeria. This contribution has the potential to revolutionize Nigerian energy landscape, offer sustainable and clean power sources that can mitigate the national dependence on fossil fuel and reduce its carbon footprint. Ogolo 2014 carried out a study on the characterization of wind speed in 20 stations covering all the climatic regions in Nigeria. It was found that arid and mineral regions had higher wind potential, up to 423 watt per meter square, while coastal area exhibited lower value. The study further identified Sokoto, Katsina, Zaria, Kano, and Jos as viable for wind energy. These studies support renewable energy adoption for climate mitigation and biodiversity conservation. Ogolo et al. 2019 assessed the wind energy potential for the generation of power in coastal and Sahel region location in Nigeria. The result of the study provided valuable information about the wind energy, wind climate in Nigeria, and identified northern areas with higher wind speed, which are generally more favorable for wind energy development. Ogolo et al. 2020 harnessed wind energy potential for power generation across 4 climatic zones in Nigeria using 12 hours nothing wind speed data, ranging from 10 meters to 100 meters high. Results show that maximum wind energy potential in the Sahel and minimum in the rest of Savannah with wind power density highest at 100 meters and lowest at 10 meters. The study confirmed that Nigeria has viable wind energy potential, particularly at 100 meters for electricity generation. We work aligned with global effort to transition to sustainable energy sources and reduce dependence on fossil fuel, climate change, and extreme events. Our extreme body of research has made significant contribution to the understanding of climate change and its impact in Nigeria and West Africa. Ogolo in 2022 examined spatial and temporal analysis of observed trend in extreme precipitation events even in different climatic zones of Nigeria from 1993 to 2017 using ground observation. The study revealed a significant decline in annual precipitation, particularly in the Savannah zone, indicating a dry trend. While the Sahel experienced increase in weather and heavy rainfall, other zones saw reduced the extreme precipitation with longer dry spell and fewer wet days, negatively affecting water resources and agriculture, as shown in figure 12 and 13. The finding emphasized the urgent need for region-specific climate adaptation strategies to address the adverse effect of extreme precipitation on agri, water resources, and food security in Nigeria. Also, Ogolo et al. 2024 investigated spatial temporal distribution of intensity and frequency of extreme temperature events over Nigeria using data from 20 snowy stations and 30 extreme temperature indices. The findings indicate a significant increase in warm extreme and a decline in cold extreme, as shown in table 2 and 3. The warming trends are more pronounced in the Sahel and Savannah region, particularly during the wet season. Rising warm extreme and declining cold extreme intensify heat stress, disrupt rainfall, and threaten biodiversity by altering ecosystem and species distribution across Nigeria. Ojo, Adeyemi, and Ogolo 2019 assessed the effect of climate change on net vegetation flood spread over 6 different climatic zones in West Africa using assessment of data from Mineral Database. The study concluded that increased population, plant cover, and topogenic activity via land use greenhouse gas emission has significantly reduced the native flood value, particularly in humid zone. This leads to surface body altered temperature patterns and more extreme weather events. Biodiversity is affected through habitat habitat loss, shifting species distribution, and ecosystem changes. This impact also threatens agricultural, water resources, and environmental stability. In addition, Matthew Ayala Ogolo 2020 focused on the impact of cloudiness on surface, near surface radiation and temperature in Nigeria, West Africa. The research uncovers significant trend in net radiation and cloud cover, which in turn reflects temperature fluctuation. This propagation of surface radiation buoyed by cloudiness resulted in net cloud radiative cooling in some regions, but warming in others, further illustrating the complexity of regional climate dynamics. Simulation and modeling. Our work, as highlighted in Ogolo 2006, 2009, 2010, 2014, Ogolo and Yaya 2014, Jekele Ogolo and Yekele 2006, Ojo and Ogolo 2015, 2017, 2020 have been instrumental in advancing our understanding of climatic processes in the region. One of our major contributions lies in the modeling of solar radiation, evapotranspiration, and net radiation, utilizing common atmospheric variables. This modeling not only enhances our ability to predict and assess the impact of climate change in the Nigerian environment, but also aid in development of strategies for sustainable resource management and agriculture. By investigating the complex relationship between these climatic variables, our research provides valuable insight for policymakers and scientists alike to facilitate informed decision making in the face of evolving climate patterns. Also, our active participation in real-time climate measurement has been invaluable for the collection of real-world data by underpinning climate models and prediction in Nigeria. Ogolo 2010 evaluated temperature and sunshine-dependent model for estimating global solar radiation across 4 climatic zones in Nigeria. Regression clusters for action time model, first, second, and third order were derived using regression analysis. Results show that third order action model did not improve accuracy as documented in the 10. It was also found that temperature-dependent models were more suitable for the Sahel region, while sunshine-dependent most perform best in the Guinea Savannah. All models perform well in Midland and coastal region. This study provides insight into selecting appropriate models for global radiation estimation based on climate and seasonal conditions. Ogolo 2004 analyzed the global solar radiation, temperature, precipitation, humidity, and sunshine hour across 30 Nigerian stations using the FDS and developing 30 modified action model incorporating meteorological and geographical variables. It was found that the modified action model enhanced with geographical variables, latitude, longitude, and elevation, have performed the originals, achieving higher accuracy, as illustrated by table 14 and 15. It was further established that relative humidity had a stronger influence than precipitation on global solar radiation estimation. This study highlights improved solar radiation modeling through multivariable integration and underscore climate variable trends in Nigeria. Ogolo and Yaya 2014 carried out a study on the validation of the evapotranspiration estimate using a locally constructed nasimeter at the Federal University of Technology, Akure. The study evaluated six evapotranspiration models and found that the Precitelo model has the best agreement with nasimeter measurement. The findings highlight the importance of accurate AT modeling for water resource management, climate adaptation, ecosystem sustainability, particularly in the tropical region. Ogolo, and Ajakari 2017 evaluated 3 techniques: Bowen ratio, aerodynamic gradient, and aerodynamic resistance (AR) for estimating sensible and latent flow using data from the Nigerian meteorology experiment conducted at the Prof. Emmanuel University in Nigeria. The study concluded that AD performed best for estimating sensible heat flow, while the Bowen ratio was more reliable for latent heat flows and energy closure. These findings, supported by figure 20, emphasize the importance of selecting appropriate technique for accurate flow measurement, estimation in agricultural and micrometeorological studies. In a pioneering study published by Ogolo 2014, my research addressed a significant gap in evapotranspiration measurement and modeling in Nigeria. My groundbreaking study calibrated 4 evapotranspiration models, active hydrogen mapping, and Priscilla across Nigerian climatic zone. Results show this is indicated on table 13. Significant coefficient adjustment. Adjusted coefficients are performed. Original validating region-specific calibration. These results significantly enhance the ability of each calculation, benefiting various applications in agricultural, water resources management, and climate study throughout Nigeria. Micro-meteorological observation and fieldwork collaboration. My commitment to advancing atmospheric research is demonstrated through my participation in both national and international field campaigns like the Nigerian Micro-Meteorological Experiment and the Dynamics Aerosol Chemistry Lab interactions in West Africa. The finding enhances our understanding of energy exchanges within the atmosphere, which are critical for climate modeling and weather prediction. These projects have provided critical data on surface energy forces, cloud interaction, and atmospheric dynamics, elevating Nigeria's standing in global climate research. Biodiversity. Biodiversity refers to the variety of life forms, including animal, plant, fungi, and microorganisms, within a specific area. Biodiversity is crucial for human survival, ecological balance, and climate change mitigation. It comprises ecosystem diversity, species diversity, genetic diversity. However, climate change driven by greenhouse gas emission and deforestation is altering ecosystem and threatening biodiversity. Effects of climate change on biodiversity. Recent studies, including that Marie 2022, Anambra 2022, Ogolo and March 2024, highlight the impact of climate change on biodiversity loss in Nigeria. Research indicates that over 20% of global species face extinction, and if temperature rise beyond 2 to 3 degrees above pre-industrial level. In Nigeria, 70% of Nigerian forests have been lost, significantly reducing biodiversity hotspot. Anambra 2024 and Ogolo and March 2024. Ecosystem disruption, such as altered plant animal interaction and habitat fragmentation, pose serious threat to endemic species. This finding aligns with IPCC 2022 warning on climate biodiversity feedback loop, emphasizing the urgent need for policy intervention. Climate change, plant technology, and crop reductions. Climate change is immediately impacting crop productivity in Nigeria. Yaya, Ogolo, and others, 2024, investigated potential changes in crop yields and phenology under projected future climate change and its implication for food security in Oyo State, southwestern and coastal north-central Nigeria. Results show that rising temperature and northern temperature pattern could reduce the yield for crops like maize and rice, while cassava yields are projected to increase adaptation strategy, such as irrigation and changes in planting rate are essential for mitigating this impact and ensuring food security. Solar radiation management. Solar radiation engineering, which involves redirecting solar radiation to mitigate climate change, holds promise for enhancing renewable energy production. Ogolo and others, 2024, show the potential impact of stratospheric aerosol injection in the photovoltaic energy potential over Nigeria. This study under solar radiation management scenario revealed regional variation with significant gain in Sahel and Guinea Savannah, but decline in coastal area. This finding highlights the need for tailored solar radiation management strategy to maximize benefits. Conclusion and conclusion. In this lecture, I presented scientific evidence on the feedback interaction between the Earth's atmosphere and terrestrial biodiversity. My research has contributed significantly to the body of knowledge improving our understanding of the Earth's atmosphere as the modulator of our climate and biodiversity. Addressing Nigeria's economy, social and environmental challenges require a strategic approach that integrates economic development with environmental sustainability. Rapid urbanization, resource exploitation, and industrial growth have led to severe environmental degradation, including pollution, deforestation, and habitat destruction. If left unchecked, these issues will undermine long-term economic stability and exacerbate social inequalities. I conclude, stressing that our God-given natural biodiversity have been significantly degraded by human activities and climate change. This has led to the loss of ecosystem services, increased frequency of extreme climate events, and negative impact on food security, human health, and national economy. Recommendation. The question is, how do we respond to biodiversity loss under future climate change? A climate smart intervention. We must adopt a variety of climate smart intervention as outlined in section 2.4.1 of this lecture. Increase research and investment. There needs to be an exponential increase in research effort recognition and investment from relevant agencies. Multi-scale approaches. We need a combination of on-ground restoration action and continual research at various spatial scales. Legal and social measures, legal instrument and social intervention include shift in lifestyle and session. Prioritization. We must prioritize our activities and avoid complacency or ignorance about the urgency of this issue. Cost of inaction. Management action requires significant investment, but the cost of doing nothing is far greater. Ladies and gentlemen, it has been a privilege to study the intricacy of our planet through the lens of science and to contribute in my small ways to understanding the atmosphere, climate, and the system that governs lives and acknowledgement. I draw inspiration from the book of Samuel, where the prophet Samuel raised his Ebenezer stone and declared, "Hitherto has the Lord helped us." Today, I raise my own Ebenezer and acknowledgement of God's unfailing help and guidance. Through moments of uncertainty, doubt, and difficulties, His hand has been evident, leading me step by step to fulfilling His purpose for my life. It is fitting to echo the words of Psalm. Bless the Lord, O my soul, and all that is within me. Bless His holy name. Bless the Lord, O my soul, and forget not all His benefits. I am reminded of the countless blessings I have received, mentorship from incredible scholars, the support of my family and colleagues, and the divine favor that has opened doors where none seemed possible. As I conclude this inaugural lecture, I cannot help but reflect on the immense grace and mercy of the Almighty God, who has been my constant guide and sustainer throughout this journey. The scripture declares in the book of Psalms, "If it has not been the Lord who was on our side." Indeed, His divine support saw me through the completion of my university education and empowered me to achieve the remarkable milestone of becoming a professor. Standing here today is evidence of His faithfulness, for as the book of Philippians reminds us, I can do all things through Christ who strengthens me. I give all the glory, all the honor to God for making me great reality, for His unending favor, for granting me the privilege to deliver this competition, to live alone, be of glory, now and forever. I would like to take a moment to express my deepest gratitude to my beloved parents, Dr. Johnson Ogolo and Madam Comfort Ogolo, God of blessed memory, who proved that you don't need a PhD to raise a professor. Despite their own lack of formal education, they were my first and best professor in the University of Life. Their solid dedication and guidance laid the foundation for my journey thus far. I am forever indebted to them. As I look back on my last journey, I am filled with a sense of nostalgia and longing. I wish that my parents were here to witness the fruit of their labor, to see the tree, the nurture of His brethren, now standing tall and strong. Special mention goes to my stepmother, late Victoria, Ogolo, and my big auntie, Madam Ogolo, of blessed memory, for the role they played in our upbringing. To my late sister, Mrs. Margaret Ogolo, I remember your love here and encouragement through. Though you may be gone, your memory lives on in my heart. A special appreciation goes to my brother Sunday, Ogolo, who literally turned my rainy day into Sunday sunshine. By providing crucial financial support after my father's death, you ensure my university education didn't end up in the weather forecast of my graduates. To all my siblings, Ogolo, blessed memory, and others of sisters, you have been my original peer review committee long before I knew what academic peer review meant. I thank you for being here for me through thick and thin. You are all the best things anyone and I feel blessed to have you in my life. I sincerely thank my president, Sir Frederick Olushola, who celebrated his 91st birthday last weekend, and the late Omonigho for their love for us and for accepting me as a son. I am especially grateful for the gift of my wife. I also appreciate my in-law family members, led by Mrs. Omonigho as listed, others as listed, for their support and kindness to all co-in-laws and extended family members. Thank you for your love and for making family gathering welcoming and joyful. It is with profound gratitude that I acknowledge the immense and invaluable contribution of both the past and the present vice chancellors of this distinguished institution, whose exceptional leadership has significantly propelled its growth and achievement, and deeply indebted to Professor under whose administration I was appointed into this esteemed university in 2004. My heartfelt appreciation goes to the late Professor Gregory, grandmother of blessed memory, who oversaw my promotion to the rank of leader in 2011 and subsequently to full professor in 2014. The immediate vice chancellor, Professor whose tenure witnessed my appointment as the head of the department of physics. A special tribute is reserved for the current vice chancellor, Professor Omonigho, his age and the first female vice chancellor of the Federal University of Technology, our visionary leadership and unwavering support have been instrumental in granting me the opportunity to deliver this inaugural lecture. I am equally honored to have served under our administration as the head of the Department of Physics from August 2022 to July 2024. Thank you. I fondly recall encouragement I received from Professor Latinda Raila, a former DVC, when I had the opportunity to attend the Dakua project meeting in Germany in 2017. Your words of support and encouragement were truly invaluable. I am also privileged to have worked with former Deputy Vice Chancellor, Academic Professor D.R. Busendi, and the current DVC Academic Professor Titi Imo. Both of you are founding chairman of Business Committee of Senate and the University Admission Committee in which I have actively served, have demonstrated exemplary leadership, vision and humility in service. Acknowledge the immediate past and current holders of key administrative roles in this university, including the Deputy Vice Chancellor, Development, Registrar, University Librarian, Dean of Postgraduate Studies, and all the serving deans of school for their invaluable support. My heartfelt gratitude to all the deans of the former School of Sciences, now School of Physical and Life Sciences, for their exceptional leadership and contribution. I particularly appreciate Professor C.O. Adejire and Professor Ari Fuakwe, under whose tenure of my leadership was announced in 2011. I also express my sincere thanks to Professor Kolade Koriko, under whose tenure I attained the rank of professor. His administrative guidance and mentorship were helpful in shaping my leadership journey. I'm grateful for the opportunity to work with Professor Ademola Adesami during my 2021 tenure as head of the Department of Physics, collaborating closely in the final year of his distinguished service as a dean. I'm deeply indebted to Dr. A.S. Afolabi, the Vice Dean of the School of Physical Sciences, for his unwavering commitment and dedication to the success of this inaugural lecture. I sincerely appreciate all the head of the department in the School of Physical Sciences for their support, especially those with whom I had the privilege of working during my tenure as the head of the department. I extend my appreciation to all professors, including other academic and non-academic staff of the School of Physical Sciences, for their unwavering support. My profound gratitude goes to all my past head of the Department of Physics, including the current head of the department, Professor Sunday Emmanuel Falado. I am indebted to all members of the Departmental Advisory Committee for the guidance I received from them during my tenure as the head of the department, including all the professors in the department. I believe from IFAC and others as listed, and other members of the academic staff, Dr. Yoromika and others as listed, especially for your collective effort in fostering academic excellence in the department. I want to especially thank Professor Emmanuel for his unflinching support and guidance, particularly his encouragement that contributed to today's event. During the second week of my appointment as the head of the Department of Physics, he inspired and not me to work as my molecular. Special recognition with that is extended to the technical and the administrative staff in the physics department, especially former head of technical, Mr. Salamoye Olasoji Martins, and the current head, Dr. Olawale Ramon Bello, and other members of technical staff as listed, including the Commander Secretary, Mr. Zedo Oyeleke, for their several commitment and contribution for the success of the Emmanuel and the rest of the family of Physics 2021-2024. Teachers, I extend my heartfelt gratitude to all my teachers who shaped my early life as St. John Primary School Tupa, St. Louis Secondary School Modern School Tupa. My appreciation goes to the teachers, to the teachers at the CSC Teachers Training College at Malaya, Ekiti State, who laid a strong foundation for my academic journey. I would like to especially acknowledge the valuable contribution of my teachers at Academic College of Education. My deepest thanks goes to Dr. Akide Fola, the former deputy provost and my former head of department, who took me in as an adopted son, offering essential service and guidance on parent support. I also recognize the impactful mentorship of late Professor D.F. Ojo, fondly called Ojo Bole, the first professor of geophysics in Africa, and the current head of the Department of Physics Afro, Dr. Rufus Akinyuke, alongside the current vice chancellor of Adeyemi University of Education, Professor Samuel Akinyola Akintunde, and others whom I've worked with, but their time will not permit me to name them all. I'm profoundly grateful to the Nigerian Federal University of Ibadan and the Obafemi Awolowo University for the exceptional knowledge and training I received during my course of study. In particular, I express my deepest appreciation to the academic father and mentor, Professor Iwo Oladina, who expertly guided me as a supervisor for both my master's thesis and PhD dissertation in atmospheric physics. Permit me to extend my heartfelt gratitude to all my esteemed colleagues, contemporaries, and my elders mentors as listeners for their invaluable contributions and guidance throughout my academic journey. I sincerely appreciate my colleagues in Wasca and the Department of Climate Science and Meteorology, especially Professor J.B. Omoto Zed Alewa and others as listed, including Professor Eso Agele of the CSP Department. I deeply appreciate your contribution and support, which have positively impacted my professional journey. My heartfelt thanks also go to Professor K.T. Badamasi for partaking the generous contribution of friends and associates toward this event. I sincerely appreciate the kindness and generosity of all my friends and associates for their golden support towards today's event. I extend heartfelt gratitude to Professor Olufemi Shadrach Akindele, the Vice Chancellor of the Lima University, for his gracious approval of the 50-seater bus that transported my family and friends to this inaugural lecture. An esteemed audience, both my academic and research activity took me outside the coastline of Futa. In this connection, I would like to express my research to appreciate my research team in Obafemi Awolowo University, University of Ibadan, Osun University, for their steadfast academic partnership. Special recognition to Dr. Ocha Owolabi, space weather scientist, for his exceptional scholarly and financial contribution, and Professor Obio, who initiated me into environmental science at Obafemi Awolowo University. Permit me to escalate my acknowledgement to Professor Diego Ojo, former head, Physics and Engineering Physics, Department, OAU, and Professor O. Jegede for hosting my 2004 sabbatical leave. The current and including the current head of the department, Professor Emmanuel Awoyemi, and all the academic staff members for their tremendous support. I'm deeply grateful to Dr. Ogolo and Atmospheric Application Institute of Ecology, OAU, for his steadfast support during this inaugural lecture preparation. I also thank Professor A.I. Ogolo, Ekiti State, Professor O.M. Oshele, Delta State, and Professor B. Rabi, Director NASA, for their encouragement and support. Back home in Futa, I thank all members of the Atmospheric Group, Futa chapter. At this junction, let me appreciate all my students, both past and present, at all levels, particularly my postgraduate students, whose research contribution have made this inaugural lecture because. Furthermore, I wish to express my sincere appreciation to an esteemed elder statesman, Dr. Albert Omonigho Akinyemi, a former gubernatorial candidate for Ondo State in the Third Republic, and the current chairman of MSc ME Forum. a business member organization of Nigeria, for its firm encouragement and steadfast support to my family. I also recognize with thanks the pivotal role Dr. Joseph Adekunle played in facilitating my admission to study atmospheric physics at the University of Ibadan in 2009. Furthermore, acknowledge the schoolmates of my wife from Baptist High School, Osogbo, including our friends from the National Education Agency, North Osun State, for their support and encouragement. My heartfelt appreciation goes to the family of Iba and Onisegban Adenikeku-san for their immense financial support. In addition, I would like to recognize Pastor Ajayi Job for his consistent support at every stage of the preparation for this inaugural. I deeply appreciate everyone who has contributed to this milestone in my academic journey. I spend my heartfelt gratitude to numerous institutions, including Ogolo University, University of Ibadan, Ekuse University, University of Ilorin, Covenant University, Anchor University, and others as listed for trusting my methodical expertise to assess the academic climate. Special thanks for letting me forecast student resident as an excellent examiner, proving that whether wisdom translates seamlessly from great ladies to great ships. Madam Vice Chancellor, I wish to express my profound gratitude to Professor Ogolo for introducing me to the fascinating field of micrometeorology. In 2010, he facilitated my participation in a field measurement campaign on energy covariance dynamics at Bansal, Germany. This trip was nationally supported by the world-renowned micrometeorologists from various universities in Germany. Professor Thomas Funke, I am immensely grateful for Professor Funke for this remarkable opportunity. I sincerely appreciate Terrestrial and the management of the Federal University of Technology Akure for supporting my participation in the 2004 Universal Symposium on Climate Research and Earth Observation in Darmstadt, Germany. This opportunity never enriched my knowledge and participation on climate research and Earth observation technology. Towards the end of my sabbatical leave at Emmanuel University, the Atmospheric Physics Group received an invitation to join an EU-sponsored project titled Dynamic Chemistry Cloud Interaction in West Africa, Dakar. Madam Vice Chancellor, I am pleased to inform this gathering that in the final report submitted to the EU, our great institution, the Federal University of Technology, was listed as one of the participating institutions in the project. In this connection, I would like to appreciate the EU project coordinator, Professor Dr. Peter Nicholas, and the field coordinator, Dr. Cornelia Klein, both from the National Institute of Technology, Germany, for invaluable support. They provided financial assistance that enabled me to attend project meeting held at the University of Leeds, United Kingdom, National Institute of Technology, Germany, and International Polytechnic Yamoussoukro, Abidjan, in 2016, 2017, and 2018, respectively. Their support has been instrumental in fostering international collaboration and advancing research within the atmospheric physics research group. I sincerely appreciate my alma mater and graduate class for their unwavering support throughout my journey. Special thanks to the alumni of CSC Teachers Training College, Efalaye, Adeyemi College of Education, District and Grade Abuja, and University of Ibadan. Spiritual leaders, I'm deeply grateful to the Redeemed Christian Church of God and our beloved daddy in the Lord, Pastor Ike Adebori, whose anointing have not only transformed my life, but also taught me that even scientists can speak in tongues. I stand and heartfelt gratitude to the former and the current regional pastors of Region 23 in particular, Pastor Omonigho Timothy, for his support. I appreciate all the national officers, provincial pastors, their assistants, our area and zonal pastors, including all the members of the Family Affairs Committee in Region 23. I am especially grateful for the current provincial pastor of Osun Province, Pastor K. Adenuga, for his prayers and support. Special thanks go to Pastor and Dr. Mrs. Emmanuel and Pastor and Pastor Mrs. Akoni, retired national head, and others as listened. Furthermore, I deeply appreciate all members of the Redeemed RCCG family in Futa. While I cannot mention anybody by name, your contribution to my journey in ministry and academia have demonstrated that God's family is truly the best research team one could ask for. Your encouragement and several support have been instrumental in shaping my life process in both ministry and personal life. Immediate family. Madam Vice Chancellor, esteemed audience, permit me at this juncture to to express my heartfelt gratitude to God Almighty for the precious gift of family He has bestowed upon me. I'm deeply grateful to my beloved children, Barrister Catherine Ogolo Adeshina, Dr. Jeremiah Sijibomi Ogolo, Dr. Mataya Ayodeji Jiro Ogolo, Engineer Praise Ogolo for their love, understanding, and general financial support towards the success of this inaugural lecture. I also cherish my grandchildren, good luck and goodness, whose joyful presence continue to inspire me. My heartfelt thanks go to my son-in-law, Prince Francis Adeshina, and my daughter-in-law, Dr. Joy Ogolo, for being such wonderful additions to my family. Distinguished ladies and gentlemen, I would like to take a moment to publicly acknowledge the valuable presence of an extraordinary individual in my life. For over 3 decades, my friend, confidence, and companion, who has stood by me through life triumphs and challenges, this remarkable person not only a destiny helper, but also an embodiment of compassion, empathy, and kindness. My beautiful wife, David, Pastor, Mrs. Oluwaboyi, Janet Ogolo, me, Ogolo, her unlimited especially grateful for our presence during my PhD oral defense, where her calming influence helped me navigate that particular point. I am blessed beyond measure to have her as my partner, friend, and soulmate. Thank you very much.
We thank Professor Ogolo for this well-delivered lecture. Distinguished ladies and gentlemen, it is customary for us to recognize some persons in our midst when we have a inaugural lecture like this. And naturally, we'll start from the home front. I'd like to recognize our own Professor Tunde Arayela, the former Deputy Vice Chancellor Academic. Thank you for always coming. I also recognize Professor Rufus Ogunshemi, is also former Deputy Vice Chancellor Academic. Thank you for always coming. We have with us a member of the University Government Council, Professor Yemisi Adeparuti. Thank you for coming. We have a former member of the University Government Council, Professor Kolade Koriko, is comfortably seated in the Kuna Center. Thank you, sir, for always coming. We have with us another member of the University Government Council, Professor Olushoga Fashionamba. Thank you very much for coming. Also with us today, we have the former acting university librarian, Professor Nike Adiolu. Thank you, Mommy, for always coming. We have with us Mrs. Zena Falaye, also former deputy university librarian in Kuta. Thank you for always associating with us. We have with us Prince Adeshina, the former librarian here in Kuta. Thank you, sir, for coming. We have with us also a member of the academic community, the representative of the Vice Chancellor at the Federal University of Education, Professor Yemi Omonigho. Thank you very much for coming. We have some of our spiritual leaders here present. Pastor Dr. Abiy Joshua from Redeemers University. Thank you, Pastor Dr. for coming. We also have with us from Ogolo University in Pastor Omonigho. Pastor Omonigho, thank you for coming. From the Teaching Hospital, Ogolo, we have Mrs. Olubukola Balogun. Thank you, ma'am, for coming. In our midst today, we have Adebayo Adenipekun, is a senior advocate of Nigeria. Thank you very much, sir, for coming. We also have with us Honorable Justice Obafemi Fasami. Thank you, Honorable sir. We recognize and acknowledge the presence. We also have with us Pastor Emeka Ezebudeyi, the supervising elder of Region 3 and 43 RCCG. Again, in our midst today, we have Mr. Ibikunle Abiodun, the retired director at the National Orientation Agency. Thank you, sir, for coming. Mrs. Kayode Comfort is a representative of the 1981 alumni set of CSC Teachers Training College, Ekwa. Thank you very much for coming. We have with us a brother to the inaugural lecturer. Is from the Nigerian Army. We have Sunday Ogolo, a brother of the inaugural lecturer. Thank you very much for coming. We have other brothers of the inaugural lecturer. We have Ogolo Abraham. Thank you very much for coming. Ogolo Monday. Thank you, sir, for coming. We have Mrs. Esther Benson, a sister to the inaugural lecturer. Thank you very much. In our midst today, we have the RCCG Regional Evangelist for Region 22, Pastor Akobi Isaac. Pastor Akobi, thank you very much for coming. We have with us Dr. Adekunbi Tosin from Adeyemi Federal University of Education. Thank you very much, sir, for coming. We want to recognize, because the inaugural lecturer is a pastor in the Redeemed Christian Church of God, we want to recognize means all pastors of the Redeemed Christian Church of God. Please just wave your hands so that we see you. All pastors of the Redeemed Christian Church of God. Thank you very much. We also recognize those that are not yet pastors. All members of the Redeemed Christian Church of God. Please wave your hands so that we can see you. Thank you very much. I join you. We recognize the old students of CSC Teachers Training College, Ekwa. Thank you very much for coming. And we recognize, thank you, sir. We recognize all families and friends from Ogolo. We have some members of the immediate family of the inaugural lecturer. We have Dr. Jeremiah Ogolo, is a son to the inaugural lecturer. Dr. Jeremiah Ogolo, thank you very much for coming. We also have Dr. Mrs. Ogolo, the daughter-in-law to the inaugural lecturer. Thank you very much for recognizing. In our midst today, we have somebody whom the inaugural lecturer described as an extraordinary individual. He described her as a friend and a destiny helper, an embodiment of compassion, empathy, and kindness. He went further to describe her as a beautiful woman. distinguished ladies and gentlemen, we recognize Pastor Mrs. Ogolo, the wife of the inaugural lecturer. Thank you very much for being a partner, a friend, and a soulmate to our inaugural lecturer. We appreciate you. Thank you very much. Distinguished ladies and gentlemen, I now recognize the most important group of people here today. Great Rotarians. You are the most important and you are the best.
Distinguished ladies and gentlemen, a couple of announcements. Our friends of the inaugural lecturer and staff of the university to go to the hilltop for their refreshments, while I will tell the students, the Rotarians, where they will go after the procession of the Vice Chancellor. Shall we all rise as we take first the future anthem and then the national anthem? Vice Chancellor's procession leaves the auditorium in the reverse order.